What if I told you that, right now, an alien traveler is racing through our solar system? Not a spaceship, not science fiction, but a real fragment from another star. A cosmic messenger called 3I Atlas. Most comets we see are local, born in the frozen outskirts of our own sun's domain. But this one is different. It has no home here. It crossed interstellar space for millions of years before slipping, silently, into our skies. And from the moment astronomers first spotted it, nothing has made sense. It glows green, yet the molecules that should cause that color are strangely missing. It surges in brightness 20 times stronger than expected, as though something is stirring within. It even carries vaporized nickel, a metal that should never escape so easily. And soon, it will sweep close to Mars, giving us a once-in-a-lifetime chance to study it not just from Earth, but from another planet. So, what exactly is this visitor? A comet behaving badly? A fragment of a shattered world? Or something far stranger? Join us as we follow 3I Atlas, the rare interstellar traveler that defies every rule we thought we knew. 3I Atlas outburst. Something strange has appeared in the night sky. It is faint, almost invisible to the casual observer, yet to astronomers it is nothing short of astonishing. In July of 2025, a small point of light was detected by the Atlas survey in Chile. At first, it seemed like just another comet, icy, distant, and unremarkable. But over the weeks that followed, it began to behave in ways no one predicted. Its name is 3I Atlas. That 3I stands for Third Interstellar Object, following in the footsteps of Oumuamua and Borisov. This small traveler is not native to our solar system. It came from somewhere else entirely, a place beyond the reach of our sun's gravity, a place among the stars. And unlike comets born in the cold outer reaches of our system, this one carries with it the mysteries of another world, another star, another history. At first, its discovery was greeted with scientific curiosity. Another interstellar visitor? Rare, yes. But the excitement was tempered by the belief that 3I Atlas would be faint, difficult to observe, and gone all too quickly. A visitor, yes, but one destined to leave little trace. Then something happened, something no one expected. By September of 2025, astronomers tracking the comet noticed its brightness was no longer following the neat, predictable curve that theory suggested. Instead of brightening gradually as it approached the inner solar system, 3I Atlas suddenly flared, increasing in brightness by a factor of nearly 20 in a matter of days. For a comet still far from the sun, over 2 astronomical units away, this was unprecedented. It was as if the comet had woken from a slumber, shaking off dust and gas in a violent, explosive exhalation. News spread quickly. Observatory reports trickled in from Hawaii, Chile, and Europe, each confirming the same extraordinary fact. 3I Atlas was no longer behaving like a simple comet. It was unpredictable, unstable, and strangely active. For many astronomers, this was a thrilling revelation. Here was a chance to witness something entirely new, to study an interstellar object undergoing a transformation right before their eyes. But for others, it carried a sense of unease. If a comet can defy expectations so completely, what else might it do? To understand why this brightening was so shocking, one must appreciate how comets usually behave. As icy bodies approach the sun, their frozen surfaces warm. Water ice sublimates, jets of gas erupt, and dust particles are released, forming a glowing coma and a trailing tail. This activity increases steadily as the comet gets closer to the sun, brightening in a way that can be modeled with reasonable accuracy. But 3I Atlas broke the rules. Its sudden flare suggested either a massive outburst, perhaps the cracking of its surface, or the exposure of a fresh reservoir of volatile ices, or something even stranger. Imagine watching a candle flame, steady and predictable, and then suddenly it surges into a bonfire with no warning. That is what astronomers saw in 3I Atlas. Its faint, steady glow became a beacon, bright enough to be tracked with instruments that had not expected to see it so clearly. And with that brightening came questions. What ices does it contain? What processes are driving its activity? Could its unusual chemistry, forged in another solar system, be responsible? The terrifying part of this outburst was not that 3I Atlas posed any danger to Earth. It will never come closer than 270 million kilometers, but rather that its behavior revealed how little we understand about interstellar visitors. Oumuamua had already defied classification, not quite a comet, not quite an asteroid, and possibly something else entirely. Borisov was more typical, resembling a familiar comet, but still unusual in its structure. And now 3I Atlas had thrown another curveball, behaving like a comet, but exaggerating its activity in ways that seemed unnatural. Scientists scrambled to collect data. The James Webb Space Telescope was quickly directed toward it, measuring its infrared spectrum to determine its composition. Ground-based observatories captured its coma, noting the faint greenish glow that accompanied its outburst. Yet the chemistry remained puzzling. Where was the usual carbon signature that gave other comets their green hue? Why did 3I Atlas seem to lack the familiar molecules, while producing unusual amounts of carbon dioxide and even metallic nickel vapor? Each answer only deepened the mystery. For the public, the headlines painted it in bold strokes. Terrifying comet brightens near Mars. But for astronomers, the terror was not physical, it was intellectual. Terrifying because here was something that challenged assumptions, something that refused to fit into tidy categories, something that reminded humanity of how vast and unpredictable the universe truly is. By the middle of September, the world's observatories were buzzing with activity. Data streams poured in, astronomers stayed awake through the night, and amateur sky watchers scanned the heavens for a glimpse of the interstellar traveler. Forums lit up with speculation. Would it fragment? Would it survive perihelion? Could it reveal secrets of planetary formation from another star system? At the same time, planetary scientists realized something else. 3I Atlas's orbit would bring it startlingly close to Mars in early October. Not close enough to be dangerous, but close enough that Mars-orbiting spacecraft could get a view unlike anything Earth-based observers could achieve. Suddenly, Mars became an observation platform, and its fleet of orbiters, MRO, MAVEN, TGO, HOPE, were given new missions. Watch the comet as it flies by. The timing was extraordinary, almost as if the cosmos itself had arranged a rendezvous. But for now, in this chapter of the story, all anyone could do was watch in wonder. A faint interstellar visitor had become a roaring beacon, a comet that defied predictions, a messenger from the stars carrying with it both answers and mysteries. Its outburst was a signal, perhaps not to us, but certainly for us, that the universe is alive with surprises. The breaking news of 3I Atlas's sudden brightening is the kind of event that reminds us why astronomy captivates the imagination. We look upward and realize that the cosmos is not static, not quiet, but dynamic and unpredictable. Comets burst, stars explode, planets align, and sometimes objects from other star systems sweep past us, giving us a fleeting glimpse into other worlds. 3i Atlas, with its terrifying flare, had become the latest chapter in this endless cosmic drama. For scientists, this was not just an opportunity, it was a responsibility. Every telescope, every spectrometer, every camera trained on 3i Atlas was a chance to learn something that might never come again in our lifetimes. Another interstellar visitor could take decades or centuries to appear. This was it. And so the call went out. Study it, track it, record it, before it fades back into the blackness of interstellar space. The breaking news was only the beginning. The real story of 3i Atlas, the story of its origin, its composition, its passage near Mars, and its ultimate fate, was just beginning to unfold. But one thing was already clear. This was no ordinary comet. It was a messenger from beyond, and its strange, sudden brightening was its way of saying, pay attention. What is 3i Atlas? When astronomers first announced the discovery of 3i Atlas, the name itself carried weight. The I designation marks it as interstellar, not a comet from our own Oort cloud or Kuiper belt, but something born around another star, from another solar system, crossing the endless void to pass briefly through ours. That 3 tells us it is only the third such object ever detected. Think about that. Out of all the billions of rocks and comets drifting through interstellar space, only 3 have ever been spotted by humanity's telescopes. Oumuamua was the first, Borisov the second, and now this one. Each is a needle in an incomprehensibly vast haystack, and each discovery marks a milestone in our understanding of the cosmos. But what exactly is 3i Atlas? On the surface, the answer seems simple. It's a comet, a body of ice, dust, and rock, perhaps a few kilometers across, moving at tremendous speed along a hyperbolic trajectory. Yet, as with all interstellar visitors, the closer we look, the more complex the answer becomes. Oumuamua, the first interstellar object, puzzled scientists with its elongated shape and lack of a visible coma. Some thought it was a fragment of rock. Others proposed an icy shard covered in an insulating crust. Some even speculated it might be a fragment of alien technology. Borisov, by contrast, behaved more like a traditional comet, producing a clear coma and tail, its behavior consistent with ices sublimating as it neared the sun. And now 3i Atlas sits somewhere in between. A comet, yes, but with characteristics that place it outside the bounds of ordinary. To understand why this matters, imagine our solar system as one neighborhood among many. Each star system has its own architecture: planets, asteroids, comets, and debris. These systems evolve under different conditions, shaped by the size of the star, the presence of giant planets, the chemistry of their birth clouds. Just as no two cities on Earth are identical, no two star systems produce exactly the same kinds of comets. So when one of these foreign visitors strays into our skies, it carries with it the fingerprints of its home system. It is a sample return mission without a spacecraft, a chance encounter that lets us study the chemistry and structure of other planetary nurseries. 3i Atlas, then, is not just a comet, it is a time capsule from another sun. The elements locked in its ice, the molecules embedded in its dust, the isotopes of its gases, all tell a story about conditions light years away. If our own comets are the frozen remnants of the solar system's birth, then interstellar comets are the fossils of other worlds' beginnings. They are fragments of alien protoplanetary disks, frozen in time, ejected into space, and now crossing our path. But how does such an object reach us? To escape its home star, a comet must be hurled outward with immense energy. Often, this happens when a giant planet, a Jupiter or Saturn of another system, gravitationally slingshots comets from their birthplace into interstellar space. Over billions of years, trillions of such objects are ejected from every star system, filling the galaxy with wanderers. Most drift unseen in the darkness, but every so often one crosses paths with our sun. When it does, its hyperbolic orbit gives it away. Unlike planets, asteroids, or comets bound to our system, interstellar objects move too fast to be captured. Their eccentricities exceed 1.0. Their trajectories are open-ended, and their speed carries them in and out, never to return. That is the story of 3I Atlas. It entered our system from the vast gulf between the stars, following a hyperbolic orbit that will carry it past the sun once, and then fling it outward again, gone forever. Its discovery was only possible because of wide-field surveys like ATLAS, robotic telescopes scanning the skies for moving objects. Without such instruments, 3I Atlas would have slipped past unnoticed, another anonymous traveler lost to the night. Its brightness at discovery was modest, but enough to catch the attention of astronomers. Quickly, orbital calculations confirmed it was interstellar. This was no icy wanderer from our Oort cloud, but something that had been drifting for perhaps millions, even billions, of years across interstellar space. The mere fact of its existence is staggering. For uncounted millennia, it has wandered starless, frozen, silent. And then, by sheer chance, its trajectory intersected with ours. What is its size, its shape, its mass? These questions remain open. Estimates suggest it is only a few kilometers in diameter, perhaps smaller. Its outburst has made it brighter than expected, but brightness does not necessarily equal size. A small, active comet can shine as much as a large, quiet one. In truth, its exact dimensions may never be known. Yet even the uncertainty is fascinating. It reflects how fragile, fleeting, and rare our opportunities to study such objects are. Scientists immediately began to compare 3I Atlas to Borisov, the second interstellar object. Borisov, discovered in 2019, was the first interstellar comet definitively observed. It looked much like a comet from our own system. It had a coma, a tail, and behavior we could model. Its chemistry, though, revealed differences. It contained unusually high levels of carbon monoxide, hinting that it may have formed farther from its parent star than most of our comets did. 3I Atlas now adds a third data point, and with each interstellar object, our picture of planetary systems beyond our own becomes richer. Consider what this means for life. Every star system ejects countless comets into interstellar space. These comets carry with them ices, organic molecules, even complex compounds. As they drift between stars, they may occasionally pass close to other systems. Some theorists suggest that such comets could seed life, or at least prebiotic chemistry, across the galaxy, scattering the building blocks wherever they travel. If so, interstellar objects like 3I Atlas are not just relics, but couriers of possibility, spreading the ingredients of life across unimaginable distances. For astronomers, however, the appeal is not just philosophical, it is practical. Observing 3I Atlas allows them to test models of cometary behavior, refine their instruments, and compare its composition against solar system comets. Already, telescopes like JWST and ground-based observatories have detected puzzling features. A green coma without the usual carbon chains, unexpected nickel vapor, high levels of carbon dioxide. Each finding is a clue, each measurement a step toward unraveling where this comet came from and how it formed. It is worth pausing to remember 3 interstellar objects in all of human history. Just 3. For centuries, astronomers scanned the skies without finding one. Only in the last decade has our technology become sensitive enough to catch these fleeting visitors. That means there are likely countless more out there, unseen, slipping past our sun without notice. 3i Atlas is just the one we were lucky enough to detect. So what is 3i Atlas? A comet, yes. An interstellar object, certainly. But more than that, it is a messenger. A reminder that the solar system is not an island, but part of a vast galactic ocean filled with drifting debris from other shores. Each object that visits us is a chance to glimpse the processes shaping other worlds. Each one is a piece of a puzzle far greater than our own small corner of space. As we watch 3i Atlas brighten and evolve, as we prepare for its close pass near Mars, we are reminded that discovery often comes not when we seek it, but when the universe chooses to send it our way. 3i Atlas is a cosmic gift, rare, mysterious, fleeting. And in studying it, we glimpse not only another world, but the connections that bind all star systems together in the grand tapestry of the galaxy. Unusual brightening. For comets, brightness is a language. It is how they speak to us across the void, whispering their secrets in faint glimmers of light. A comet's glow tells us about its size, its chemistry, its distance, and its activity. For centuries, astronomers have learned to read this light like a script, charting comets as they approach the sun, predicting how they will shine and fade. And yet, every so often, a comet refuses to follow the script. It behaves as though it has a mind of its own. That is exactly what happened with 3i Atlas. When it was first discovered in July 2025, 3i Atlas appeared faint, unremarkable, a small visitor drifting quietly through the night sky. Predictions suggested it would brighten steadily over the coming months, following a curve we could chart with confidence. This is what comets do. They approach the sun. The ices on their surfaces heat up. They release gas and dust, and they grow more luminous. A slow, graceful crescendo. But 3i Atlas had other plans. In early September, astronomers noticed something startling. Instead of brightening in a predictable, gradual arc, 3i Atlas suddenly surged. Within days, its brightness increased nearly 20-fold, a violent, unexpected flare that caught even seasoned comet watchers off guard. One observatory compared the change to a whisper becoming a shout overnight. For an interstellar object still more than 2 astronomical units away from the sun, twice the distance between Earth and the sun, this was extraordinary. It should not have been so active, so bright, so alive. The news rippled through the astronomical community. At first, some suspected an error. Perhaps instruments had misread the light. Perhaps atmospheric interference had exaggerated the glow. But as observatories across the world confirmed the same result, the reality set in. 3i Atlas was undergoing an outburst. Something deep within its icy body had shifted, fractured, or erupted, releasing a torrent of gas and dust into space. What causes such outbursts? In comets from our own solar system, they can occur when volatile ices, carbon monoxide, carbon dioxide, even nitrogen, suddenly sublimate, triggered by fractures in the surface crust. Sometimes a pocket of gas that has been trapped for eons breaks free, venting explosively into space. Other times, structural stress causes part of the comet's surface to collapse, exposing fresh, unweathered ice to sunlight, igniting rapid sublimation. Whatever the mechanism, the result is the same: a sudden, dramatic increase in brightness. But 3I Atlas is not an ordinary comet. It carries with it the scars of a journey through interstellar space, battered by cosmic rays, frozen in the endless dark for millions or even billions of years. Its chemistry is not identical to the comets we know. The elements and molecules locked within it were forged in a different star system, under different conditions. So, when it flared, it was not simply a cometary tantrum, it was a revelation. Imagine watching a sleeping volcano erupt with no warning, spewing fire into the sky. That is what astronomers witnessed in September 2025. The faint interstellar traveler became a beacon, glowing with an intensity that drew eyes from every corner of the Earth. For a brief moment, the comet was brighter than anyone had predicted it would be, even at its closest approach to the Sun. It was as though the comet was announcing itself. I am here. Pay attention. The timing of the outburst added to the mystery. At over 2 astronomical units from the Sun, 3I Atlas should still have been relatively inert. Water ice sublimates at shorter distances, closer to where the heat is stronger. At this range, activity should have been modest, driven perhaps by carbon dioxide or carbon monoxide ices, which sublimate more easily at lower temperatures. But the sheer scale of the brightening suggested something more dramatic, either an unusually large reservoir of volatile ices or a structural collapse exposing vast new areas of fresh material. Neither explanation was fully satisfying. To make matters more intriguing, the glow that accompanied the outburst was tinged with a faint green. This was puzzling. Normally, the greenish hue in cometary comas is produced by diatomic carbon, C2 molecules released from the nucleus. Yet early spectroscopic data on 3I Atlas suggested a surprising lack of these carbon chain molecules. Instead, what was detected in abundance was carbon dioxide gas, along with traces of nickel vapor and cyanogen. These are not the usual culprits behind a green coma. So why was the comet glowing as though it were rich in C2 when the data suggested otherwise? This contradiction became one of the first great mysteries of 3I Atlas. Was the carbon simply hidden, masked by other emissions, waiting to be revealed as the comet drew nearer to the Sun? Or was some entirely new process at work, something not seen before in solar system comets? If the latter, then 3I Atlas was not only an interstellar traveler, it was a messenger carrying a chemistry alien to our skies. The surge in brightness also had practical consequences. Telescopes that had once struggled to detect 3I Atlas suddenly found it much easier to observe. Instruments that had been scheduled for other targets were rapidly redirected. The James Webb Space Telescope captured infrared spectra, ground-based observatories recorded detailed images, and amateurs with modest backyard equipment joined in, their cameras capturing the ghostly glow of the alien comet. For a brief window of time, the whole world seemed to be watching the same thing, a strange visitor from beyond, screaming into the dark with unexpected brilliance. Some astronomers were reminded of Comet 17P Holmes, which in 2007 underwent a similar dramatic outburst, brightening by nearly 500,000 times in a matter of hours. That comet became visible to the naked eye almost overnight. Could 3I Atlas follow a similar path? Would its outburst make it a spectacular sight even for casual stargazers? Or would it fade just as quickly, a firework extinguished before its time? No one knew, and that uncertainty only deepened the fascination. The word terrifying began appearing in headlines, though not in the sense of imminent danger. 3I Atlas poses no threat to Earth. it will never come closer than 270 million kilometers. The terror was of another kind, the terror of the unknown, the unsettling realization that the universe can still surprise us, that our models and predictions are not infallible. For scientists, this is both humbling and exhilarating. To be confronted by nature's unpredictability is to be reminded of why we study the cosmos at all. Every surge of brightness, every spectral anomaly, every flicker of green light was a data point, a clue in the unfolding mystery. And beyond the data lay the wonder. Here was an object born around another star, altered by forces we cannot fully imagine, and now, for a fleeting moment, blazing in our skies. Its unusual brightening was not merely a scientific puzzle, it was an encounter with the unknown, a reminder of how much remains to be discovered. As September turned to October, the comet's activity continued to fascinate. Would there be more outbursts? Would it fragment under the stress of its own activity, as some comets do? Or would it hold together, surviving its journey toward the sun and offering us months of observation? No one could say. But one thing was certain. 3I Atlas was no longer just a faint point of light. It was a phenomenon, a performer on the cosmic stage, and all eyes were upon it. And so, astronomers prepared for the next act. For soon, 3I Atlas would pass close to Mars, offering a chance for spacecraft orbiting the red planet to observe it up close. The unusual brightening was just the prologue. The true drama, the encounter with Mars, the speculation about its nature, the unfolding of its chemistry, was still to come. Close encounter with Mars. There is something spine-tingling about the idea of two wanderers of the cosmos coming close to one another, each on their own journey, each bound by the laws of gravity and motion. Planets follow their orbits like clockwork. Comets fly along their hyperbolic or elliptical paths. For the most part, these paths cross at a distance so vast it is difficult even to imagine. But every now and then, celestial mechanics conspires to bring them close together, and when it does, the universe offers us a spectacle. That is what will happen in early October 2025, when 3I Atlas, the third known interstellar object, sweeps past Mars. To understand why this encounter matters, we must first remember the rarity of the situation. Interstellar visitors are already astonishingly uncommon. We have only ever detected 3. For one of them to pass close enough to a planet for detailed observation is an astronomer's dream. This is not a simulated mission or a carefully planned flyby like those of spacecraft. This is nature itself offering us a chance to look closely at a messenger from another star system, with Mars serving as our cosmic observation post. The numbers themselves tell the story. On October 3, 2025, 3I Atlas will pass within about 28 million kilometers of Mars. In cosmic terms, this is a hair's breadth. It is nearly 70 times closer to Mars than it will ever come to Earth. To put it in perspective, Earth and Mars are separated by hundreds of millions of kilometers at their closest approach. Here, the comet will skim past Mars at a distance close enough for spacecraft orbiting the red planet to turn their instruments outward and capture an interstellar comet from an entirely new vantage point. For scientists, the timing feels almost miraculous. When 3I Atlas was first discovered, its orbit appeared to keep it comfortably away from any planets. But as weeks passed, refinements to its trajectory revealed something astonishing. Its path would intersect Mars's orbital neighborhood. The comet will not strike Mars, nor will it come close enough to disturb the planet in any meaningful way. Gravity at that distance is negligible. but it is close enough to offer a unique observational opportunity. And in science, that can make all the difference. Picture it, a fleet of robotic spacecraft orbiting Mars, their cameras and spectrometers usually trained on the planet below, suddenly reoriented to the heavens above. The Mars Reconnaissance Orbiter, with its powerful high-rise camera, capable of resolving features just a few meters across on the Martian surface, will attempt to capture the comet against the starry background. The Trace Gas Orbiter, with its sensitive instruments designed to study Mars's thin atmosphere, will turn its attention outward, hoping to sniff the faint gases escaping from 3I Atlas's Coma. The MAVEN mission, built to understand Mars's upper atmosphere, will repurpose its ultraviolet spectrometer to analyze the comet's emissions. And even the Emirates Mars mission, better known as HOPE, will join the campaign, its instruments gathering data to add to the collective effort. It is a symphony of science, coordinated across agencies and nations, all focused on a tiny point of light racing through the Martian sky. From the perspective of those orbiters, 3I Atlas will not be just another star. It will be a moving target, a living comet, glowing with gases and dust, carrying the chemistry of another world. For the first time in history, humanity will study an interstellar object not just from Earth, but from a second planet. The possibilities are breathtaking. From Mars, the comet will appear brighter and larger than from Earth, making spectroscopic studies more detailed. Instruments could detect subtle signatures in its gases, revealing not just what is escaping from its nucleus, but how that chemistry differs from anything we know. Is the carbon dioxide ratio higher? Are there strange isotopes? Are there unexpected metals? Every detail offers a clue about the conditions in the star system where 3I Atlas was born. The very geometry of the encounter adds intrigue. As the comet flies past Mars, it will create a rare alignment. Earth, Mars, and the comet positioned so that data can be gathered from multiple vantage points. Earth-based telescopes will watch from afar, while Mars orbiters provide close-up detail. This stereoscopic view could allow astronomers to map the comet's coma in 3 dimensions, to measure how dust and gas flow differently depending on perspective. It is like watching a performance from both the balcony and the front row simultaneously. For the public, the phrase "close encounter with Mars" carries a thrill of danger. Is the comet a threat? Could Mars be struck? The answer is no. At 28 million kilometers, the comet will sweep harmlessly past. But that closeness fuels the imagination. We picture ancient skies when comets were seen as omens, and imagine what it would be like to stand on the Martian surface, looking up as an alien comet streaks across the sky. The symbolism is hard to miss. Mars, long the target of human curiosity, will play host to a visitor from another star. Our robotic emissaries, orbiting the red planet, will act as intermediaries, capturing data on our behalf. In a way, Mars becomes an outpost of human science, not just for planetary study, but for interstellar exploration. It is as though we are reaching a little farther into the cosmos, using Mars as a stepping stone to bridge the gap. But beyond poetry lies hard science. The encounter offers a once-in-a-lifetime chance to resolve a key question. What makes interstellar comets different? Borisov taught us that some behave much like our own. Oumuamua taught us that some may behave like nothing we have ever seen. 3I Atlas, with its sudden outbursts and puzzling chemistry, seems poised to teach us something new. By observing it near Mars, we gain a perspective no Earthbound telescope could provide. We may learn whether its strange brightening is caused by surface collapse, by unusual volatiles, or by processes we cannot yet name. There is also the possibility of surprise. Space missions often reveal things no one anticipated. Perhaps the comet's coma will be more structured than expected, with jets visible even at great distances. Perhaps its tail will interact with the solar wind in unusual ways, creating shapes never before seen. Perhaps its light curve will spike again during the Mars encounter, throwing models into chaos. Each outcome would add to the sense of mystery, the recognition that the universe is not bound by our expectations. And then there is the sheer drama of the moment. For days around October 3rd, astronomers will hold their breath, waiting for data from Mars orbiters to arrive on Earth. Each transmission will carry the fingerprints of another world, captured from a platform hundreds of millions of kilometers away. It is science at its most thrilling, distant, uncertain, and profoundly meaningful. For 3I Atlas, the encounter with Mars is just a brief moment in its long journey. After millions of years adrift in interstellar space, after weeks of brightening and surprising, it will glance past the red planet and continue on its hyperbolic path toward the sun. But for us, that moment will be immortalized. It will be recorded in spectra, in images, in the memories of those who witnessed it. It will stand as proof that even in the vast emptiness between stars, there are moments of connection, moments when the trajectories of distant travelers intersect with our own. When future generations look back, they will remember not just the comet itself, but the encounter, the time when Mars and an interstellar comet shared a stage, and humanity, watching from two planets, bore witness. And they will see it as one of the early steps in our expanding presence in the cosmos, a reminder that exploration is not confined to where we send spacecraft, but includes the visitors that come to us, unbidden from the stars. The close encounter with Mars is not the end of 3I Atlas's story. After Mars, it will continue toward the sun, its brightness waxing and waning, its chemistry unfolding. More mysteries will emerge, more debates will rage. But October 3rd will be remembered as the day when an alien comet brushed past our planetary neighbor, and humanity, for the first time, reached out from two worlds to meet it, observing from Mars. There is something almost poetic about the idea, a comet born around another star system, after wandering through the galaxy for perhaps millions of years, arriving in our skies just as we have outposts of our own circling Mars. For the first time in history, we will not observe an interstellar comet solely from Earth. We will observe it from two planets. Mars, the world that humanity has dreamed of visiting for centuries, will now serve as a cosmic balcony from which to watch the passage of 3I Atlas. The importance of this cannot be overstated. Earth's atmosphere, while a gift for life, is a constant hindrance to astronomy. Light is scattered, distorted, absorbed. Ground-based telescopes peer through a shifting lens of air, relying on adaptive optics to sharpen their view. Space-based telescopes like Hubble and JWST eliminate this problem, but they are few, oversubscribed, and limited in what they can see. But Mars, thinly veiled in its own atmosphere, with orbiters carrying a diverse suite of instruments, offers a fresh perspective. It is as if the universe has handed us a second set of eyes, a second chance to study an interstellar visitor from a different vantage point. When 3I Atlas passes within 28 million kilometers of Mars in October 2025, it will be bright enough to be seen by multiple spacecraft. Each of these orbiters carries instruments that, while designed to study Mars, can be repurposed to examine the comet. The most famous among them is NASA's Mars Reconnaissance Orbiter, MRO. Its high-rise camera has given us stunningly detailed images of Mars's surface, showing dunes, avalanches, even the tracks of rovers. High-rise is capable of extraordinary resolution, down to less than a meter on the Martian ground. From orbit, it can spot objects the size of a dining table. Turned outward, it will attempt to capture 3I Atlas as a point of light against the stars, its brightness fluctuating, perhaps even its coma or jets faintly visible. ESA's Trace Gas Orbiter, TGO, will play another role. Designed to study Mars's atmosphere in fine detail, TGO carries spectrometers that can detect minute concentrations of gases. Redirected toward 3I Atlas, these instruments will attempt to dissect the light of the comet, splitting it into spectra that reveal its composition. What molecules are escaping from its icy body? How do their ratios compare to solar system comets? Is its chemistry familiar or alien? Already, early data from Earth suggests unusual amounts of carbon dioxide, a depletion of common carbon chains, and even vaporized nickel. TGO could confirm or refine these measurements, adding an invaluable second perspective. Meanwhile, NASA's MAVEN mission, launched to study the upper atmosphere of Mars, carries an ultraviolet spectrometer known as IUVS. This instrument is uniquely suited to studying comets because many gases, hydrogen, oxygen, carbon, glow brightly in the ultraviolet. MAVEN will watch 3I Atlas as it passes, measuring the faint fingerprints of its gases in ultraviolet light. In doing so, it may answer questions Earth-based instruments cannot, such as how much water vapor is being released, or how the solar wind interacts with the comet's coma. Even the Emirates Mars mission, HOPE, launched by the UAE, may contribute. Its EMUS spectrometer, like MAVEN's, can detect ultraviolet emissions. Together, the two spacecraft could triangulate data, observing the same gases from different positions. It would be like listening to a symphony with two microphones placed at different parts of the hall, allowing scientists to reconstruct the performance in richer detail. There is a striking symbolism in this. Humanity, still confined to one planet, now has robotic emissaries circling another. And those emissaries are not only studying their host planet, they are turning their gaze outward, toward an object from another star. Mars becomes, in this sense, not just a target of exploration, but a platform for exploration. It is our second laboratory, our second listening post, our second window on the cosmos. What might we learn from these observations? First, we may confirm the comet's composition with far greater certainty. Earth-based observations are already puzzling. The green coma suggests diatomic carbon, but spectra show little of it. Instead, there are signatures of carbon dioxide, cyanogen, and metals like nickel. Why the contradiction? Perhaps Mars orbiters will detect weak emissions that Earth's instruments missed. Perhaps they will reveal isotopic ratios that tell us where the comet formed, closer to or farther from its parent star. Perhaps they will find entirely new molecules, unseen in solar system comets. Second, we may learn more about the structure of the coma itself. Comets often release gas and dust in jets, which can create asymmetries, spirals, and other structures. From Earth, these are hard to resolve unless the comet is very close. From Mars, the geometry changes. Orbiters may be able to detect subtle variations in brightness that hint at active jets or rotating features. If 3I Atlas is venting material unevenly, this could explain its sudden brightening and unusual orbit shifts. Third, we may learn how an interstellar comet interacts with the solar wind. The The sun is constantly streaming particles outward, and when these collide with a comet's coma, they can create bow shocks, tails, and magnetic effects. MAVEN, with its instruments tuned to study atmospheric escape on Mars, is perfectly positioned to measure these interactions on the comet. The data could reveal whether interstellar comets behave differently in the solar wind than local ones do, offering clues about their surface properties and internal structure. But perhaps most importantly, the observations from Mars represent something larger than science. They represent a step forward in how humanity explores the universe. We are no longer limited to a single vantage point. For the first time, we can study an interstellar visitor from two worlds simultaneously. That kind of multiplanetary science was once the stuff of fiction. Now, it is reality. There is also the chance for surprise. No matter how carefully missions are planned, space has a way of humbling us. Perhaps the comet will undergo another outburst just as Mars passes close, lighting up the orbiter's instruments with unexpected brilliance. Perhaps fragments will break off, creating multiple points of light. Perhaps the coma will swell larger than anticipated, or its tail will stretch across the Martian sky in ways never seen before. Any of these outcomes would send scientists scrambling, rewriting theories, and debating late into the night. Imagine, too, what it would be like for a human observer on Mars. Standing on the cold, dusty surface, under a thin sky-tinted pink, you look up. There, brighter than the stars, glows 3I Atlas, a comet from another system, passing through your alien sky. For now, only our robotic surrogates can witness this. But perhaps one day, when humans do walk on Mars, they too will see such wonders firsthand. 3I Atlas reminds us of that possibility. As October approaches, anticipation builds. The commands have been sent to spacecraft, the observation plans carefully laid out. Scientists wait, watching the countdown, knowing that the data returned could transform our understanding of comets, planetary systems, and even the galaxy itself. For weeks afterward, the raw data will pour in: spectra, images, brightness curves. Each file will be scrutinized, debated, interpreted, and slowly a picture will emerge of what 3I Atlas truly is. In many ways, the encounter is a rehearsal for the future. The European Space Agency's Comet Interceptor mission, scheduled for launch later this decade, is designed to wait in space until another interstellar object appears, and then fly out to meet it. 3I Atlas arrived too soon for such a mission, but the Mars observations give us a taste of what is possible. They show how much can be learned by positioning instruments in the right place, at the right time. They demonstrate the value of being ready, of seizing the moment when the cosmos sends us a visitor. And so, as 3I Atlas sweeps past Mars, humanity will watch from two planets: Earth, with its great telescopes and space observatories; Mars, with its orbiters repurposed into comet-chasing instruments. Together, they will capture an interstellar comet like never before. It is an extraordinary alignment of chance, preparation, and curiosity. And in that alignment lies the essence of exploration: the willingness to look outward, to adapt, to see opportunity where once there was only distance. In the silence of space, 3I Atlas will continue on its way, unaware of the eyes upon it. But for us, this moment will echo. It will be remembered as the first time humanity studied a visitor from another star, not just from our home world, but from a second planet, a milestone, a glimpse of the future, a reminder that the universe is vast, alive, and full of surprises, and that we are, slowly but surely, learning how to meet it with open eyes. Speculation versus science. Whenever the cosmos delivers something new and puzzling, the human imagination responds in kind. The moment a discovery breaks the mold of what we expect, speculation fills the gaps. Astronomers measure light curves and chemical spectra. Engineers write models and refine orbital calculations. But for the wider public, mystery often becomes myth, and the unknown is recast as something extraordinary. This dynamic has played out with every interstellar object we've encountered, and 3I Atlas is no exception. When Oumuamua, the first interstellar visitor, streaked through our solar system in 2017, it captured more than just scientific interest. Its strange shape, its lack of a visible coma, its unexplained acceleration, all of these left scientists searching for answers. Some suggested it was a fragment of a planet, others a frozen shard of nitrogen ice. And then came the provocative hypothesis from Harvard astronomer Avi Loeb. What if Oumuamua was not natural at all, but an artifact of alien technology? A solar sail, perhaps, pushed gently by sunlight, gliding between the stars. The idea was controversial, yet it stuck in the public imagination. Suddenly, Oumuamua was no longer just a comet or an asteroid. It was a mystery tinged with possibility. The second interstellar visitor, Borisov, seemed more ordinary, more comet-like. It showed a coma and tail consistent with sublimating ices. Yet even here, the fact that it carried unusually high levels of carbon monoxide sparked questions about how different its home system might be. And now comes 3I Atlas, with its erratic outbursts, puzzling chemistry, and close approach to Mars. Once again, the line between cautious science and wild speculation is being tested. As soon as 3I Atlas began to brighten in unexpected ways, whispers started. Some asked, could it be controlled? Could its sudden surges of activity be intentional maneuvers, not random outbursts? Its trajectory, after all, seemed almost too perfect, passing close to Mars in a way that promised detailed observation. The timing of its brightening, the peculiar chemistry of its coma, the odd green glow, each became fuel for the fire of speculation. Avi Loeb once again entered the debate. In a paper released shortly after the discovery of 3I Atlas, he posed the question directly. Is 3I Atlas alien technology? It was not a claim, but a provocation, a reminder that science advances by considering all possibilities, even extraordinary ones. He noted that the object's path through the solar system brought it unusually near several planets, and that its outbursts might resemble controlled outgassing, like thrusters firing. Could it be a probe? A derelict spacecraft? A fragment of something artificial, launched by a civilization far older than ours? For many scientists, the answer was simple. No. The peculiarities of 3I Atlas, they argued, could be explained by natural processes. Comets outburst all the time. Their surfaces crack, their ices vent, their brightness flares unpredictably. The chemistry, while strange, was not impossible. The green glow could be due to subtle emissions, the nickel vapor a rare but not unheard of phenomenon. And the trajectory? That was the product of celestial mechanics, refined by constant measurements, not the steering of an alien pilot. Dr. Tom Statler, NASA's small bodies lead scientist, was quick to emphasize this point. All the evidence we have is consistent with a comet, he said. An unusually interesting comet, yes, but natural nonetheless. For Statler and many others, the alien technology hypothesis was not just unlikely, but unnecessary. Nature provides plenty of ways for comets to surprise us. Invoking extraterrestrial intelligence was, to them, a distraction from the real science. Yet speculation persisted. Online forums buzzed with theories. Some imagined 3I Atlas as a scout sent ahead of an alien fleet. Others wondered if it might be a derelict probe, drifting for millennia, its systems failing, its outbursts nothing more than the sputtering of ancient engines. A few even suggested it could be a fragment of something larger, an alien megastructure shattered long ago, its pieces now wandering the galaxy. Why does the alien hypothesis have such appeal? Partly, it is because interstellar objects already feel uncanny. They are not of our solar system. They come from places we cannot see, bearing chemistries we do not fully understand. To imagine them as alien artifacts is to bridge the gap between the unknown and the extraordinary. It is a narrative as old as humanity. When something strange arrives from afar, we imagine it as a messenger. But science demands discipline. Carl Sagan's old dictum applies. Extraordinary claims require extraordinary evidence. For Oumuamua, no such evidence emerged. For 3I Atlas, the same holds true. The brightening can be explained by volatile ices. The odd chemistry may reflect a different birthplace. The trajectory is hyperbolic, not guided. Until evidence emerges that defies natural explanation, the safest conclusion is the simplest one. 3I Atlas is a comet. Still, even within the realm of science, there is room for wonder. A natural comet from another star is no less extraordinary than an alien probe. Consider what it represents: a fragment of another solar system, ejected into the galaxy, drifting for uncounted ages, and now passing through ours. Its chemistry tells us about the environment of its birth. Its behavior reveals the stresses of interstellar travel. Its very existence confirms that planetary systems everywhere are dynamic, chaotic, and interconnected. Speculation and science, then, are not enemies, but companions. Speculation inspires curiosity, draws attention, sparks imagination. Science grounds us, tests hypotheses, builds understanding. In the story of 3I Atlas, both play a role. The alien theories capture headlines, but the data, the spectra, the light curves, these are what will remain, what will teach us, what will endure, and perhaps that is the real lesson. The cosmos is vast enough that both the natural and the extraordinary can coexist. Comets outburst, stars explode, planets align, and somewhere, perhaps, civilizations may indeed send probes between the stars. But until we find evidence, the interstellar visitors we meet are messengers of nature, not technology. They are reminders that the universe is alive with processes we are only beginning to understand. In the end, whether 3I Atlas is a comet or something more exotic, it challenges us in the same way. It asks us to look up, to question, to wonder. It forces us to confront the limits of our knowledge, to acknowledge both the rigor of science and the allure of speculation. It is not just a ball of ice and dust. It is a mirror, reflecting our hopes, our fears, our imagination. As data pours in from Earth and Mars, the verdict will become clearer. The outbursts will be charted, the chemistry cataloged, the orbit refined. Each observation will chip away at the mystery, replacing speculation with science. Yet even as the comet becomes more familiar, it will retain its aura of wonder. For in the end, the most extraordinary truth may be the simplest: that across the galaxy, countless worlds give birth to comets, and some of them, by chance, come to visit us. 3I Atlas is one such visitor, not an alien spacecraft, not a harbinger of doom, but a traveler, a fragment of another world, carrying within it the story of its birth, its journey, and its brief passage through our skies. To call it a comet is not to diminish it, but to honor what it truly is: a natural wonder, a cosmic messenger, a reminder that we are part of a galaxy alive with motion and mystery. And so, speculation gives way to science, science gives way to understanding, and understanding gives way to awe. The debate may continue, the theories may multiply, but the comet itself is silent. It does not explain. It does not argue. It simply passes by, glowing green, venting gas, blazing in the sunlight, a mystery that needs no embellishment. The mystery of its chemistry. Light is the language of the cosmos. When distant objects whisper across the void, they do so not with words, but with photons, tiny messengers that carry information about what they have touched, what they have become, and what they are made of. For astronomers, decoding that light is an act of translation. Each wavelength, each color, each faint spectral line is a letter in a cosmic alphabet. And when scientists turned their instruments toward 3I Atlas, the third interstellar visitor ever discovered, they expected to read a familiar script. But what they found instead was a puzzle. It began with color. To the human eye, or to cameras with the right filters, comets often appear tinged with green. This is not mere poetic flourish. It comes from chemistry. The green glow is usually produced by diatomic carbon, C2. Molecules released as ices on the comet's surface vaporize. Under the influence of solar ultraviolet radiation, these molecules fluoresce, radiating a green hue that can surround the nucleus like a ghostly shroud. Astronomers have grown accustomed to this signature, using it as a shorthand for activity. A green comet is an active comet. So when 3I Atlas began to glow faintly green after its sudden outburst, it seemed to fit the pattern. But spectroscopy, the dissection of light into its component wavelengths, told another story. Instruments on Earth and in space searched for the telltale fingerprints of C2, those sharp bands of emission that confirm its presence. Instead, they found little to none. The green was there, but the molecule that usually produced it was absent or vanishingly scarce. It was as if someone had written a sentence in bright green ink, but left out the letters that should have formed the words. If not C2, then what? Spectra revealed other players. Carbon dioxide gas, far more abundant than in most solar system comets. Cyanogen, a rare but known component, faintly present. And most puzzling of all, vaporized nickel, a heavy metal rarely detected in cometary comas, and even then only in trace amounts. None of these should produce a green coma. None of them explained the hue that telescopes were seeing. This contradiction became the central enigma of 3I Atlas. How could it glow green without the usual culprit? Was there another molecule at work, one that fluoresced in a way we did not fully understand? Was the carbon there, hidden beneath detection thresholds, waiting to be revealed as the comet neared the sun? Or was this truly an alien chemistry, a signature of a comet born in conditions radically different from those of our own solar system? To appreciate the strangeness, we must consider what comets are. In our solar system, they are time capsules, frozen remnants of the protoplanetary disk that formed the planets. Their chemistry reflects the temperature, pressure, and radiation environment of that ancient nursery. Some formed closer to the sun, rich in water and silicates. Others formed farther out, where carbon monoxide and methane could freeze. Over billions of years, their surfaces have been weathered by cosmic rays, their interiors preserved in deep cold. Now imagine a comet formed around another star. Its chemistry depends on that star's light, its protoplanetary disk, its giant planets stirring material, outward or inward. The balance of ices, gases, and metals could be very different. And if such a comet is ejected into interstellar space, it spends eons bombarded by cosmic rays in the deep dark, its outer layers transformed in ways we can barely model. By the time it arrives in our system, it carries a chemical fingerprint unlike anything we have seen before. 3I Atlas, then, may be telling us a story. Its carbon chain depletion, its lack of C2, suggests it may have formed in a region poor in complex carbon molecules. Perhaps its parent star's protoplanetary disk had a different balance of carbon and oxygen. Perhaps giant planets swept carbon-rich material away before it could freeze. Or perhaps cosmic rays, over millions of years in interstellar space, destroyed fragile carbon compounds, leaving behind only more resilient molecules. The abundance of carbon dioxide is another clue. CO2 is less common in our comets, at least near the surface. Yet in 3I Atlas, it seems plentiful, suggesting it either formed farther from its star, where CO2 could condense in abundance, or that its surface chemistry has been altered in unusual ways. Nickel vapor adds a further twist. Metals are not expected to sublimate easily. They are locked in dust grains, released only under extreme heat. That 3I Atlas should show nickel at this distance hints at processes we do not yet understand. Perhaps cosmic ray sputtering, or hidden reservoirs of volatile metal compounds. Each of these mysteries pushes us to think beyond our solar system. For the first time, we are tasting the chemistry of another star's nursery, and it does not taste quite like ours. The absence of C2, the dominance of CO2, the presence of nickel, all of these are signatures of a different recipe, a different kitchen, a different chef. And just as a single spice can change the flavor of a dish, so too can small differences in chemistry reshape the evolution of worlds. Scientists debate these findings fiercely. Some argue that the green coma must still be due to C2, simply at levels too low for current instruments to confirm. Others propose that another molecule, perhaps C2H2, acetylene, or exotic radicals, could be fluorescing in unexpected ways. Still others suspect that the green glow is an illusion, the result of overlapping spectral lines misinterpreted by telescopes. Only further observation, particularly during perihelion, will clarify the truth. But in a deeper sense, the very existence of the puzzle is the point. It is a reminder that our models, built on solar system comets, cannot capture the full diversity of the galaxy. 3I Atlas forces us to expand our imagination, to consider chemistries we have never seen, to admit that our experience of comets is parochial, shaped by a single system. There is also the tantalizing question of life. Comets are carriers of organic molecules, amino acids, carbon chains, precursors to the chemistry of biology. If 3I Atlas is depleted in these, what does that mean? Was its home system poorer in the building blocks of life? Or did interstellar radiation destroy them? And if so, does that suggest that not all star systems are equally fertile, that some may be barren deserts while others are rich gardens? The chemistry of 3I Atlas is not just a curiosity, it is a probe into the conditions that make planets, atmospheres, and perhaps even life itself. By studying its strange coma, we are glimpsing the diversity of planetary systems, the richness of the galaxy's experiments. Some systems may produce carbon-rich comets, seeding planets with organics. Others may produce carbon-poor comets, limiting the pathways to life. The galaxy, it seems, is not uniform but varied. And 3I Atlas is one data point in that grand distribution. As it approaches the sun, the mystery deepens. Will more carbon appear as fresh layers are exposed? Will new molecules emerge, flashing into spectra like signatures across the stars? Will the green glow intensify, fade, or transform into something entirely new? Each day, each observation adds to the story. And even if we never fully solve the puzzle, we will have learned something profound, that the chemistry of the universe is stranger, richer, and more varied than we imagined. Standing back, it is hard not to feel awe. Here is a comet, a frozen fragment of another world, glowing green in our skies, taunting our instruments, defying our models. It is as though the universe has handed us a riddle, and we must work together to solve it. Some answers will come from Earth, some from Mars, some from space telescopes. But the riddle itself, the fact that it exists, is the gift. For in puzzles, science thrives. And so the mystery of its chemistry remains. A green glow without carbon, carbon dioxide in abundance, nickel where there should be none. Each piece of data is a clue, each clue a doorway into the unknown. As 3I Atlas sweeps closer to the sun, we will continue to watch, to measure, to question. And in doing so, we will be reminded that the universe is not a book already written, but a story still unfolding, full of twists, contradictions, and surprises. 3I Atlas is that surprise, a comet that glows without the molecules we expect, a messenger from another star, carrying with it a recipe that does not match our kitchen, a riddle written in light, waiting for us to decipher. And perhaps, in that effort, we will not only learn about another world, we will learn about ourselves, about the limits of our knowledge, and about the endless curiosity that drives us to look up, to ask questions, and to chase the mysteries written in the stars. What happens next? The story of 3I Atlas is not finished. In fact, the most dramatic chapters are still ahead. Every comet carries with it a script written by physics and chemistry, a story that unfolds as it draws closer to the sun. Some comets flare brilliantly, dazzling the sky with spectacular tails. Others fragment, breaking into pieces that vanish into the void. Some fade quietly, their reservoirs of ice exhausted before they can put on a show. For an interstellar comet like 3I Atlas, the possibilities are even wider, even stranger. What happens next is a question no one can answer with certainty. But the outlines of the comet's journey are clear, and each stage carries with it both promise and peril. The first milestone is perihelion, the comet's closest approach to the sun. For 3I Atlas, this will occur around October 30th, 2025, when it dips to about 1.4 astronomical units from the sun, just inside the orbit of Mars. At that distance, the solar heat will intensify dramatically. The ices on its surface will warm, volatile gases will erupt, and its coma and tail may grow to extraordinary size. This is the moment when comets often become most active, their true natures revealed by the heat of our star. For astronomers, perihelion is both a climax and a gamble. Will 3I Atlas flare spectacularly, giving us a once-in-a-lifetime show? Or will it break apart under the stress, another comet lost to the sun? As perihelion approaches, Earth-based telescopes will face a problem. The comet's apparent position in the sky will bring it close to the sun from our perspective, hidden in the glare of daylight. Observing it will become difficult, then impossible, for weeks. This period, known as solar conjunction, is a frustrating time for astronomers. The comet will be at its most active, its most unpredictable, and yet Earth will be blind to it. Instruments like the Solar and Heliospheric Observatory, SOHO, and the Parker Solar Probe may catch glimpses, but for the most part, we will have to wait. That waiting will be filled with tension. Will the comet survive perihelion? Many do not. As heat and tidal forces build, fragile structures can fracture, splitting a comet into fragments. Some dissolve into dust, leaving behind only faint trails. Others emerge battered but intact, continuing their journeys. For 3I Atlas, the outcome is uncertain. Its earlier outburst suggests a volatile, unstable body, prone to sudden activity. That could mean it is already weakened, vulnerable to disintegration. Or it could mean it is resilient, rich in volatiles, capable of putting on a spectacular display. Then comes December 2025, the moment when the comet re-emerges from behind the sun. By early December, it will once again be visible from Earth, faint at first, then brighter as it continues outward. This is when astronomers will know whether it has survived. If it has, it may offer some of the best observational opportunities yet. On December 19th, 2025, 3I Atlas will make its closest approach to Earth, about 1.8 astronomical units, or 270 million kilometers. This is not close in everyday terms, but in astronomical terms, it is the best chance we will ever have to study it. From this distance, telescopes across the globe will train on it, capturing every detail of its spectrum, its coma, its tail. Space-based observatories like Hubble and JWST, if allocated time, could collect data of unprecedented clarity. Ground-based giants like the Very Large Telescope and Keck will add their strength. And amateurs, with cameras and binoculars, will search the skies for a glimpse of the interstellar visitor. By then, the Mars orbiter data will have been analyzed, adding a second perspective to the Earth-based view. Together, the two sets of observations will create the richest portrait yet of an interstellar comet. Astronomers will compare its chemistry to that of Borisov and our own comets, building the first real catalog of interstellar diversity. Is 3I Atlas typical of its kind, or an outlier? Do other planetary systems produce comets like ours, or are their recipes entirely different? Each answer will ripple outward, shaping our theories of how planets form, how solar systems evolve, how matter circulates through the galaxy. And then, slowly, inevitably, the comet will fade. Having rounded the sun, having flared and perhaps fragmented, 3I Atlas will drift outward. Its path is hyperbolic, open-ended. Gravity will not bring it back. Once it departs, it will be gone forever, a traveler continuing its journey into the interstellar dark. Perhaps in another million years, it will pass near another star, another system, becoming someone else's mystery. But for us, its story ends here. What happens next is not just about the comet, it is about us. How will we respond to this fleeting visitor? Will we learn all we can, gathering data with urgency, knowing the chance may not come again in our lifetimes? Will we use its passage to inspire new missions, new telescopes, new ways of being ready when the next interstellar traveler arrives? Already, ESA's Comet Interceptor mission is preparing to wait in space, ready to launch toward the next surprise visitor. 3I Atlas is a reminder of why such missions matter. For the public, what happens next may also be about wonder. If the comet survives perihelion and brightens, it may become visible even to the naked eye, glowing faintly in the night sky. To look up and know that you are seeing an object from another star system, that is a perspective-shifting experience. It collapses the vastness of the galaxy into a single point of light, tangible, visible, shared. Of course, there is also the possibility of disappointment. The comet may fragment during perihelion, leaving nothing but dust and faint trails. By December, it could be gone, a ghost of itself, visible only in data archives. Yet even this would not diminish its importance. The act of disintegration would itself be data, telling us about its structure, its fragility, its limits. Even in death, the comet would teach us. And so, we wait. The next chapters in the story of 3I Atlas are unwritten, and the cosmos does not reveal its plot twists in advance. But one thing is certain: whatever happens, it will be remarkable. We are witnessing history, the rare crossing of paths between our solar system and another. A frozen messenger has come to us, carrying the chemistry of another world, and what happens next will shape our understanding of the galaxy we call home. In the silence of interstellar space, 3I Atlas has traveled for eons, unseen, untouched, unremarked. Now, for a brief moment, it is ours to study, ours to wonder at, ours to remember. Its future is uncertain, flare, fragment, fade, but its legacy is secure. It will remind us, long after it is gone, that the universe is alive with motion, that worlds are not isolated but connected, that the story of our solar system is part of a larger, grander tale. What happens next? We will watch, we will measure, we will learn. And when it is over, when 3I Atlas slips back into the dark, we will know a little more about the galaxy, and perhaps a little more about ourselves. A rare visitor. The universe is a theater of motion, and most of its actors never leave their assigned stage. Planets orbit their stars, asteroids circle within belts, comets wander out and back again, tethered by the gravity of their parent suns. Everything seems bound, predictable, rehearsed, and yet, every so often, a traveler appears who does not belong, a wanderer from another neighborhood, another system, another history. These are the interstellar objects, and they are so rare that in all of humanity's centuries of watching the skies, we have seen only 3. Oumuamua, Borisov, and now 3I Atlas. To call it a rare visitor almost understates the truth. The galaxy is vast, filled with trillions of such fragments drifting in the dark. But space is also inconceivably empty, and only the tiniest fraction of these fragments ever stray close enough for us to notice. That we have seen 3 in less than a decade is a sign that our instruments have become powerful enough, sensitive enough, to catch them. But for all the rest of human history, they passed by unseen. Think of it, countless alien comets ghosting through the solar system, unremarked, forgotten. Now, at last, we are beginning to notice. And of those 3I Atlas may be the most remarkable. Not because it is the largest, it may not be. Not because it is the brightest, though its sudden outburst has made it unusually visible. Not even because it passes near Mars, though that in itself is extraordinary. No, 3I Atlas is remarkable because of the questions it leaves us with. It glows green without the molecules we expect. It flares with an energy that seems disproportionate to its distance from the sun. It carries nickel vapor and carbon dioxide in strange proportions. It is a riddle wrapped in ice and dust, a puzzle launched from another sun. What do we do with such a riddle? We observe, we measure, we debate. Data streams from Earth's telescopes, from Mars orbiters, from space observatories. Spectra are pored over, light curves analyzed, models tested. Scientists argue, papers are published, hypotheses proposed. Some are cautious, insisting that everything can be explained by natural processes. Others are bolder, suggesting new chemistries, even alien technologies. But beyond the arguments lies something deeper: awe. Awe that we are even here to ask these questions. Awe that we can catch such a fleeting visitor in our instruments. Awe that the galaxy is not silent, but filled with travelers carrying stories from afar. The rarity of such visitors means that each one is precious. Oumuamua came and went so quickly that we barely had time to look. Borisov gave us a better chance, behaving much like a comet, confirming what we thought we knew. 3i Atlas offers something in between, familiar and unfamiliar, predictable and surprising, comforting and unsettling. It is the bridge between the known and the unknown, and for a brief moment it is ours to study, but soon it will be gone. That is the melancholy truth of interstellar objects. Their orbits are open-ended, hyperbolic. They come once and only once. Gravity does not bring them back. After December 2025, after its closest approach to Earth, 3i Atlas will drift outward, fading into darkness, never to return. It will pass the orbit of Jupiter, then Saturn, then Neptune, then leave the solar system behind. It will travel for millions of years, perhaps brushing past another star, perhaps wandering aimlessly in the void. To us, it will become just a memory, a set of data, a story told, and yet its legacy will endure. For every student who looks at its spectrum, for every amateur astronomer who photographs its coma, for every curious mind who reads about it, 3i Atlas becomes a teacher. It tells us that planetary systems across the galaxy are dynamic, chaotic, ejecting fragments into the dark. It tells us that chemistry is diverse, that not every comet carries the same molecules. It tells us that the galaxy is connected by these wanderers, that matter does not stay confined, but circulates, crosses borders, shares its secrets. There is something profoundly humbling in that. For all our technology, for all our telescopes, we are still dependent on chance. We cannot summon interstellar objects at will. We cannot plan their visits. We must wait patiently for the galaxy to send them, and when they come, we must be ready. 3i Atlas is a test of that readiness. Did we observe quickly enough? Did we allocate telescope time? Did we turn Mars orbiters outward? Did we share data across nations? The answer is yes. Humanity has risen to the occasion, just as we did with Borisov, just as we tried with Oumuamua, and each time we are better prepared. Looking forward, missions like Comet Interceptor will change the game. They will wait in orbit, ready to pounce when the next interstellar traveler appears. They will not just watch from afar. They will fly alongside, sample the coma, photograph the nucleus, bring us close enough to see detail. But until then, we must rely on chance encounters like 3i Atlas. And in that sense, this comet is not just a rare visitor. It is a rehearsal, a preview of the science to come. But perhaps the greatest gift of 3i Atlas is not scientific, but human. To look up and know that a point of light in the sky is from another star system, that is a perspective few experiences can provide. It collapses the unimaginable distances of the galaxy into something tangible, visible. It reminds us that we are not isolated. Our solar system is not a lonely island. We are part of a galaxy filled with countless other systems, countless other comets, countless other stories. And some of those stories come to us, carried in ice and dust, glowing faintly against the night. In the end, the phrase rare visitor carries a double meaning. Rare because such objects are seldom seen, but also rare in the sense of precious, valuable, irreplaceable. 3i Atlas is both. It is a fleeting guest, one we will not see again, one we must cherish while it is here. And it is a gift, a reminder of the universe's richness, a spark of wonder in a sky too often taken for granted. So what should we remember? That three-eye atlas flared brighter than expected, glowing green with puzzling chemistry. That it swept close to Mars, giving us a chance to study it from two planets. That it carried with it mysteries we may not fully solve, but which will inspire us to try. And that it will soon be gone, continuing its endless journey, leaving us wiser, more curious, more aware. Above all, we should remember that we are lucky. Lucky to live in a time when telescopes can detect such things. Lucky to have spacecraft orbiting Mars, ready to look outward. Lucky to witness, even for a moment, a fragment of another world passing by. In the grand sweep of cosmic history, our lifetimes are brief, our instruments new, our reach limited. And yet, we caught Three-Eye Atlas. We saw it, we studied it, we were here. The universe is vast, the stars are many, the distances are unimaginable, and yet, sometimes, across that emptiness, a visitor arrives, rare, precious, brief. That is Three-Eye Atlas, a comet from another star, a messenger from another time, a reminder that the galaxy is alive with motion and mystery. It comes, it glows, it teaches, it leaves. And we, the watchers, are left with wonder.